Hello my pre-calculus student. In this video we are going to find the value of inverse sine, inverse cosine and inverse tangent. For a function to have an inverse, it has to be 1 to 1. So to test a function to be 1 to 1 so that we can find inverse, we have to use the horizontal line test. So you get a horizontal line. If the horizontal line only intersects the graph at one point, in this case the function f of x is a 1-to-1 function. However, the function g of x is not 1-to-1 function because the horizontal line intersects the graph more than one point. So now let's look at the sine function. Make sure you write the note down for us. Okay, so for the sine function, first you can see right here that the graph of the sine function doesn't pass the horizontal line test. So we have to restrict the sine function. It means that you go back to the graph and you will say that we only take one piece of the graph. So the piece that we are going to pick will be the piece that's closer to both x-axis and y-axis and pass through the point 0, 0. So we take this piece right here. So the domain for this piece will be from negative pi over 2 to positive pi over 2. Now we are going to look at, on the right hand side, this is the graph of the inverse function of sine. Now there are two ways that we can write the inverse function of sine. We can write as sine with the -1 on the exponent, so this is inverse sine of x, or we can write it as sine. Now you make a note for yourself that the notation inverse sine of x doesn't equal to the reciprocal. It means 1 over sine x. So do not confuse when you use your calculator. You say, oh, inverse sine x is the same thing as I put 1 divided by sine x. No, they are not equivalent. So you can see right here that from the after we restrict the sine function, we have 3 points. So the first point on the left hand side, this point will be negative pi over 2, comma -1. So now when we graph the inverse, we have to interchange the x and the y. So now x become y, y become x. So now the points on my inverse will be -1, comma negative pi over 2. So you can see right here that both the x-axis and the y-axis, they also interchange too. So now the x-axis go from -1 to 1 because this is the range of our sine function. So the range of the sine function becomes the domain of the inverse function. And the domain for the sine function becomes the range for the inverse sine. So now you can see that your x and your y value is interchanged. So now let's plot the next point. So the next point, so there are three points. So the points in the middle will be 0, 0. Now since the x value and the y value is the same, so when you plot, you will see that it's still the same point, 0, 0. Let's look at the last point. This point is pi over 2, comma 1 for the sine function. Now for the inverse of sine function, you have to interchange, you have to flip this. So now the point be 1, comma pi over 2. So that is how you graph the inverse of sine function. So first you start to graph the sine function first, and then you only pick a piece from the graph of the sine function. So you restrict the domain of the sine function, and then you pick 3 points, and then you can flip that 3 points, and then plot the new 3 points on the inverse of sine function. Now remember that the domain of our sine function becomes the range for the inverse sine function. The range for the sine function becomes the domain for the inverse sine function. And for the inverse sine function, we can write them as the odd sine of x. So you can see right here that when I find the inverse sine, my domain will be all real number between -1 and 1, which is my input, and my output, which is the answer or the range, will be from -pi over 2 to pi over 2. So let's use that concept to evaluate. So this is the unit circle. We are going to find the inverse of sine. So we want you to find inverse of sine of 1/2. So the first thing you have to do is that I'm going to go to my unit circle, and I'm going to just focus because the domain for my inverse is only go from -1 to 1. So I make sure I'm going to write down the note right here, domain for inverse sine of x is from -1 to 1. Then you're welcome to erase the other half of your circle so that you don't have to take a look at that. So what I'm looking at, I'm just looking at half of my circle from -1 to 1. Okay. The range for my inverse function, the range for inverse of sine of x is from -pi over 2 to +pi over 2. So that's what we keep in mind right now. So I'm going to go here. So this is 0, 0. If we go counterclockwise, will be positive angle. If we go clockwise, be negative. So this angle, the same thing as -30 degrees. This angle, the same thing as -45 degrees. And this is -60 degrees. And this will be -90 degrees. Now it will. Now if we're looking at the radian or the odd length, this will be -pi over 6. This will be -pi over 4. This will be -pi over 3. And lastly be -pi over 2. So now we are going to look at the interval from -pi over 2 to pi positive pi over 2. And we're looking for the y because sine is a y. So let me make a note for you here. We need to find a point on the unit circle with y coordinate of 1/2. So here we are. I'm going to go look. I'm looking for y coordinate is 1/2 here. So we found it. So then therefore we can conclude that inverse of sine of 1/2 is, remember the rank, which is the degrees or the odd length in radian. So the answer will be pi over 6, or you can answer in degrees. So inverse sine of 1/2 is 30 degrees. So pi over 6 radian or 30 degrees. Now we can check our answer. So you will do sine of pi over 6. So go sine of pi over 6. The answer is 1/2. Check. So any questions? Yeah. So just make sure that when we find the inverse of sine, our input will be the number from -1 to 1. Our output will be the angle in degree will be from -90 degrees to positive 90 degrees, or the odd length in radian will be from negative pi over 2 to positive pi over 2. Okay, now let's look at the inverse of cosine. So the first thing you have to do, again, you need to graph the cosine function. So this is the graph of the cosine function. If you remember the pattern of the y value being y equal 1, y equal 0 at pi over 2, y equal -1, y equal 0, and y equal 1. And then again, the set of phi y value just repeats itself, and it's like the letter V. So the first thing, again, we are going to restrict the cosine function. So we only take one piece of the cosine function, because we have to make sure that we pick one piece so that it will pass the horizontal line test, right? Because if you pick the entire graph, the graph of cosine or the graph of sine, it doesn't pass the horizontal line test. So pick one piece, and the next step we're going to do is we'll pick 3 points on the piece. So the point right here be 0, 1. The point right here be pi over 2, 0. And the point right here will be pi, -1. So now you have the 3 points, and then you are going to graph the inverse of cosine by interchanging that 3 points. So the point 0, 1 now become 1, 0. And the point pi over 2, 0 become 0, pi over 2. So you can see that the two axes, the x-axis and the y-axis, is also interchanged, right? So now your x-axis is go from -1 to 1. Because why? Let's go back and look at this piece again. This piece this piece of the cosine function, it has the domain from 0 to pi. it have the range from -1 to 1. However, when you do the inverse, the domain become the range become the domain. So the domain now become the range. So the range for the inverse will be from 0 to pi. And the domain for the inverse of cosine be from -1 to 1. So that's why you can see right here that my x value go from -1 to 1, and my y value for the inverse cosine will go from 0 to pi. So now we just go ahead and take the 3 points, we interchange the x and the y value, so we flip it, x become y, y become x, and we plot that 3 new points on the inverse cosine function. So the last point will be -1, pi. So this is the graph of inverse cosine. So we make sure that we remember the domain for inverse cosine will be go from -1 to 1. The range, which is the output, will go from 0 to pi. So let's look at the unit circle again. And we want to find the inverse cosine. So inverse cosine, and make sure we make us a note that the domain will go from -1 to 1. The range we go from 0 to pi. So it means I'm going to my unit circle, the range go from 0 to pi, so it means I only need to look at this half of the circle from 0 to 180 degrees. Now I'm going to use this half of the circle to find inverse cosine of any input from -1 to 1. So let's find inverse cosine of square root of 2 over 2. So the first thing you have to do is that you will find a point on the unit circle with the x coordinate of square root of 2 over 2. So I'm going to go and look for my x coordinate. So here we are. So we found that therefore, or then we can conclude that inverse cosine of square root of 2 over 2 will be the radiant of the arc length be pi over 4, or you can answer in degrees. Inverse cosine of square root of 2 over 2 will be 45 degrees. So both answers exactly the same terminal side, pi over 4 radian or 45 degrees. Now let's do the one last one, which is inverse tangent. So this is the graph of tangent. So the first thing we have to do is that we have to restrict the tangent function again, because if we take more than one period, it's not going to be 1 to 1. So this is the period of tangent. Periods is pi. So what we're taking is that we only take one period of tangent. And then again, the vertical asymptote, we have two vertical asymptote x equal negative pi over 2. It becomes horizontal asymptote y equal negative pi over 2. And again, inverse of tangents, you can write as this notation with the negative 1 on your exponent, or you can write it odd tangent. So they both exactly the same. And make a note for yourself that the notation inverse of tangent of x, it doesn't equal to the reciprocal 1 over tangent. So make a note, the same thing with inverse of cosine and inverse of sine. So the second vertical asymptote is x equal positive pi over 2. When we graph the inverse tangent, that becomes the horizontal asymptote y equal positive pi over 2. Then you pick 3 points inside the graph, 1, 2, 3. So the point right here will be negative pi over 4, negative pi over 4. Okay, so the points will be negative pi over 4, comma negative 1. So when I graph on my inverse, I flip it, so I interchange the x and the y to become negative 1, comma negative pi over 4. Okay. So again, the middle point be 0, 0, stay the same. The third point for the graph of tangent is pi over 4, comma 1. So for the inverse will be 1, comma pi over 4. So now you have the graph of inverse of tangent. Again, let's compare the domain and the range. So the domain for our tangent function, if I just look at one period only, it goes from negative pi over 2 to positive pi over 2. We do not include the left end and the right end because these are the two asymptotes, so we have to use parentheses. The range, which is the y value, so the graph will be all real numbers on the y-axis. But when we go to the inverse function, the domain now becomes the range. So the range will go from negative pi over 2 to positive pi over 2. And the range of our tangent becomes the domain for our inverse function. So the domain will go from negative infinity to positive infinity. So now we can see that the domain and the range of our tangent function will be interchanged with the domain and the range of our inverse tangent. So now we are going to use this concept to find the inverse tangent. So let's find the inverse tangent of, let me open my unit circle first. Okay. So we want you to find inverse tangent of square root of 3. Okay, so first we want to make a quick note for the inverse tangent. The domain and the range. So the domain will be from negative infinity to positive infinity. The range will go from negative pi over 2 to positive pi over 2. So we can look at our unit circle right here. This is positive pi over 2. So this will be negative pi over 2. If we go clockwise, so therefore we only look half of the circle, and we do not want to include the 2 endpoints. So I'm just go ahead and erase. Actually, maybe I just go ahead and leave it right here for you. So let me just go ahead and start with our input is square root of 3. Now the domain will be all real number. It means it doesn't matter. Our input can be whatever number, but our answer will be all the number between negative pi over 2 to positive pi over 2, but do not include the two endpoints. So the first thing we have to do is that we have to find a point. So we need to find the point x, y on the unit circle such that tangent of that angle, I don't know what the, so tangent of theta is y over x and have to be equal square root of 3. So we can see right here that at the point where my y is square root of 3 over 2 divided by, so right here, this is the point. Someone says sin tangent of pi over 3 equal y over x will be square root of 3 over 2 over 1/2. So this will give me square root of 3 over 1, or just square root of 3. So therefore, then I can conclude that inverse tangent of square root of 3 is pi over 3, or 60 degrees. So let's go ahead and write out the summary. In this video, we learned how to find the value of inverse sine, inverse cosine, and inverse tangent. Thanks for watching. I will see you in class. Goodbye.